everyone, and thank you for tuning into LearnCast. My name is Mahrusa, and today we're going to be talking about ionic bonding. So to start off, we're going to be talking about ions and the basics of ionic compounds. But what exactly are ions? Ions are basically just a charged atom. An atom that has a different number of electrons and protons. How do they form though? So an atom always wants to be stable, and in order to be stable, it needs to have a full outer shell of 8 valence electrons. A neutral atom can gain or lose electrons in order to have a full outer shell. This would make it become an ion with a certain charge. So let me give an example. Oxygen has 6 valence electrons when it's neutral, and so in order to have a full outer shell of 8, it needs to gain 2 electrons. So since it gained 2 electrons, it'll have a charge of -2. Another example would be potassium, which has 1 valence electron when it's neutral. In order for it to have a full outer shell, it'll lose that 1 electron, and it'll get a charge of +1. So generally, you can figure out the charge of an atom by looking at its location on the periodic table. Like how everything in the first column has 1 valence electron, everything in the 6th column has 6 valence electrons, and so forth. Transition metals, though, are a bit more confusing since they have more than one possible charge. This is a bit more difficult, but we'll talk about this later. One thing to note, however, is that silver and zinc both have 1 charge even though they're transition metals. Silver will always have a charge of +1, and zinc will always have a charge of +2. So as you'll see later, all these charges of different atoms and elements, they'll become really important in this unit. So a general trend is that metals lose electrons to become cations, which are positive ions, and non-metals gain electrons to become anions, which are negative ions. And a cation and an anion bond to form an ionic compound. The composition of the ionic compound will depend on the charge of these ions. And it's not just single elements. Polyatomic ions are also an ionic compound. And just like elements, their charges will affect the composition of the compound. So the positive and negative charges in the compound, they attract each other. And so this creates a super strong bond in the compound. This is why ionic compounds have really high melting points and boiling points. The ions are also arranged in a crystal lattice with a really structured shape. Another characteristic of ionic compounds is that they can conduct electricity when they're in a solution. So that was just a brief summary of the characteristics of ionic compounds. Now let's talk about the chemical formulas and the binomial nomenclature for ionic compounds. So binomial nomenclature is the method of naming 2-part compounds, such as obviously the ionic compound. So here are the steps to use binomial nomenclature to name an ionic compound. So as you know, an ionic compound consists of a cation and an anion. So you want to keep the name of the cation as it is, don't change it. And then for the anion, there's 2 ways to do it. If the anion is a single element, like a nonmetal, then you change the name of that nonmetal so that it ends in ide, IDE. So here's an example. Li2O. We'll deal with the numbers later, but for now let's just talk about Li2O. So that's lithium and oxygen. So remember, keep the cation as is and the nonmetal end in ide, so it's lithium oxide. Let's have another example. Mg3N2. Again, we'll deal with the numbers later, but we have magnesium and nitrogen. Using the rules of binomial nomenclature, we're gonna call it magnesium nitride. And the second way to name the anion is that if it's a polyatomic ion, then you keep the name as is and don't change it. So for example, you have NaOH. That's sodium and hydroxide, which you don't change either of them, sodium hydroxide. And another example, K3PO4 is just potassium phosphate. And naming transition metals are a bit trickier, so we're gonna talk about this at the end of the podcast. Right now, let's jump ahead into chemical formulas of an ionic compound. So one thing that's really important to remember is that the chemical formula of an ionic compound is the formula unit. It's a ratio. It's not the total number of atoms like in a molecule. For example, H2O, water, has 2 hydrogens and 1 oxygen, but K2O isn't 2 potassiums and 1 oxygen. K2O means that the ratio of potassium to oxygen ions is 2 to 1. the chemical formula of an ionic compound doesn't represent the total number of ions in the compound. So all the numbers that you hear in an ionic compound, they're known as the subscript. They're like the teeny little numbers that you write on the bottom right of an element. So to get the subscripts for the chemical formula of a compound, we need to know the charges of the ions. And so the best way to demonstrate how to do this is through an example. Let's start with beryllium fluoride. So to start off writing the chemical formula for this compound, obviously just write the symbols first. And so the symbols of the elements in this compound are Be for beryllium and F for fluorine. So just write Be and F. Now we get to the numbers part. So a beryllium ion has a charge of +2 and fluorine has a charge of -1. So I want you to write these charges on the top right of the elements. So for Be, just write a teeny little +2 on the top right and write a -1 on the top right of the F. Now we're gonna do something called the crisscross method. You basically just switch them. So listen carefully. You put the charge of one element into the subscript of the other element. So you have the +2 on top of the Be. Now put the 2 under the F. The 2 is the subscript for fluorine. And then you have the -1 on top of fluorine. Put the 1 under the beryllium. So Be has a subscript of 1, which basically you don't need a subscript. So this makes BeF2. And this is the chemical formula for beryllium fluoride. Here's another example. This time with a polyatomic ion. Let's figure out the chemical formula for magnesium sulfate. So the first step is to write the symbols Mg and SO4, and then you want to write the charges. So you put +2 on the top of Mg, and then you put -2 on the top of SO4. And now you want to do crisscross. So the +2 on Mg goes under SO4. So you have SO4 and 2. One thing to note here about polyatomic ions is that if they already have a subscript, like here, sulfate already has a little 4, you want to put parentheses around the polyatomic ion and then put the subscript underneath. So you have SO4 parentheses 2, and then sulfate's charge of -2 will go to Mg. So you write 2 under Mg. So now you have Mg2 SO4 parentheses 2. And remember that chemical formula is a ratio for an ionic compound. So you have Mg2 SO4 2, so you can simplify the subscripts. So you get Mg SO4. For this example, we didn't need the parentheses, but I just wanted to teach you how to use polyatomic ions in compounds. So we talked about before how transition metals have multiple possible charges. So in compounds, they tend to come with a Roman numeral when you name them, and this Roman numeral represents their charge. So once you figure out their charge, follow the same process to find the compound's formula. Let's start with an example again. Iron 3 oxide. So once again, write the symbols Fe and O. So since they mention iron 3, iron has a charge of +3, and obviously oxygen has a charge of -2. And now let's do crisscross. The +3 of iron goes under the oxygen, and the -2 of oxygen goes under the iron. As a result, you have Fe2O3, and that is the formula for iron 3 oxide. Let's do another one. This time, let's do iron 2 oxide. So once again, write the symbols like we did before, Fe and O. But this time, iron has a charge of +2 instead of +3. Oxygen still has -2. And so you crisscross, the +2 of iron goes to oxygen, the -2 of oxygen goes to iron, so you have Fe2O2. And then you want to simplify here, so you get FeO, and that's the chemical formula for iron 2 oxide. So now that we've figured out how to name ionic compounds with transition metals, we can go back to binomial nomenclature for transition metals. And this takes a bit of work and a bit of time, and so I saved this for last. Again, it's easier to show it through an example, so let's get right to it. So here we have CuCl2, and so here we have the subscripts, but we don't know the charge, at least for copper. So you want to do reverse crisscross. So you still switch them, but this time you do it in the other direction. The subscript of one element should make the charge of the other element. So the subscript of Cu is 1. If there's no subscript, we assume it's 1. And so that goes to Cl, which makes it -1. And then the subscript of Cl, which is 2, goes to Cu, so that the charge of Cu, copper, is +2. Now that we know the charge of copper, we can name this compound. Since copper's charge is +2, the name of this compound is copper 2 chloride. Remember, you want to write copper's charge in Roman numerals. So it's copper, parentheses, II, chloride, just to make it clear. Here's a trickier example, Fen. So you want to do reverse crisscross. Both of them have subscripts of 1, so the charge of Fe becomes +1, and the charge of nitrogen becomes -1. Do you notice something? I just said that nitrogen's charge is -1. But isn't nitrogen's charge always -3? So how do you get -3 from here, from -1? So in order to do that, you want to multiply both charges by 3. This is like reverse simplifying. So now, after multiplying both by 3, iron now has a charge of +3, and now nitrogen has a charge of -3. And so now you know the charge of ion, +3. The name of this compound is iron 3 nitride. And that's it. That's all I have for now. So just to summarize, in this lesson, we went over ions, ionic compounds, and how to write their names and their chemical formulas. Thank you so much for joining me on our review of ionic bonding. Be sure to follow us on Spotify, subscribe to our YouTube channel, and check out our website to stay up to date with the latest releases. Until next time, remember to listen, learn, and repeat.